Welcome everybody to this side event on mineral resources. So this side event is organized by the University of Bergen and the Academia Europaea, the European Academy's Bergen hub. And we have a very nice panel for you. And I'll say a few words by introduction about the theme, and then we will have a series of relatively short talks, and then a panel debate where there is a possibility to ask questions also from the audience. I'll sit down so you know that I'm following the schedule. Both the pandemic and the effects of the Russian invasion of Ukraine highlights our dependence on various types of resources and the control and transport of these. Critical mineral resources are required for our transition to a climate-friendly society, but some of them, or many of them, are under control of authoritarian regimes. And production of resources are often unjust and unethical. And the demand is predicted to increase by orders of magnitude in the future. Vast quantities of mineral-rich deposits have been found in deep-sea areas, including deep-sea regions of the Arctic and subarctic. And many of these are related to hydrothermal vents on near the ocean, mid-ocean ridges, far from land and at high depths. So while the International Seabed Authority has granted exploration licenses in various locations, in particular in the Pacific Ocean, several countries are planning to initiate exploration within their own jurisdiction, and Norway being one of them. So the green transition generates a need for critical minerals, expected to be greater than the supply from existing land-based mining industry. Or does it? Or from recycling? Is Norway in a position to become a leader in the exploration for deep-sea minerals if we decide to do this? The race has apparently started. And this event will address both challenges, opportunities, and dilemmas. So, does the green shift really need deep-sea minerals? Can we do without them and depend more on switching to a circular economy? Do deep-sea minerals have a potential for creating new industries? Is the technology advanced enough? Do we have the knowledge base needed to safely explore these resources without irreversible damage to surrounding ecosystems? How is Norway preparing for its first licensing round? And how will this influence the Arctic region? Is the Norwegian Act on mineral activities on the Continental Shelf, the Seabed Minerals Act, a sufficient regulatory framework? And finally, can deep-sea minerals extraction be sustainable enough to be justified? To discuss this with us and to present a broad picture of both the situation and the dilemmas, we have an illustrious panel of panelists. First, Andrew Bloodworth, who is a geologist and policy director from the British Geological Survey, and Andrew will join us via Zoom. His work is on resource security and critical raw materials, regulatory issues associated with minerals extraction and the impact of mining in the developing world. We have Walter Sognes, he will also join us by Zoom, from Loke Minerals in Stavanger. It's one of the startups targeting this potential industry. He has long experience in the oil and gas industry. We have Kaja Lønnefjørtoft, who is a biologist, senior advisor for sustainable oceans in WWF, Norway, who is with us here. and with experience from the Norwegian Environmental Policy and Regulation Authority. Pedro Ribeiro, who is also here, he is a Portuguese, but works at the Center for Deep Sea Research at the University of Bergen, biodiversity expert. And we have Anita Paulo, who is a US citizen expert on Arctic shipping, energy and infrastructure. She has a law degree from Oxford, is a Fulbright scholar, author, contributes to blogs, and much more. And Paula was advisor to the Harvard-MIT Arctic Fisheries Project and founding team lead for the DC-based Wilson International Center Polar Code Project. So without further ado, I will give the floor first to Andrew. So if we then switch to Zoom here. Hi, Andrew.
Hi.
Nice to have you with us.
Thank you. It's very nice to be with you. I'm sitting in the deepest countryside in East Anglia in the UK. So I hope the internet, our Wi-Fi link stays up okay. Is it okay if I share my screen now?
Yeah, please, and please give us your presentation.
Okay, thank you. You got that okay? Yes, I can see it. Yeah, okay. Thank you very much for inviting me to speak today. I'm not a deep sea mining specialist. As the chair said, I've got more general interest in raw material supply and critical raw materials, particularly those associated with the energy transition. I'm not going very long, so I'm going to press on quickly. So, what's driving demand? Well, what's driving demand for these things is global population growth. We're looking at around 9 to 10 billion people on the planet by the end of the century. Of course, what's also driving demand, again, the chair mentioned it, is the need for us to transition our economy from a fossil fuel-based economy, emitting lots and lots of greenhouse gases into the atmosphere, into a net zero economy, a green economy. And that means a massive transition in the types of materials that we use. That combination of the energy transition, population growth, and the aspirations of many, many people around the world, particularly in what are currently low middle income countries, to live like we do, to live in a middle class sort of way with all the stuff that we surround ourselves with, and there's no getting away from that. But that low carbon system that we're aspiring to is much more material intensive than the fossil fuel based economy. And so our global materials use is slated to grow very rapidly over the next century. People say we're moving from an age of petroleum to an age of metal. And that's engendered a lot of concerns about supply, and again, the chair's already mentioned that. But it's important to say these supply security concerns and criticality, if you like, concerns, are not new. They've been a recurring theme in history, particularly over the last 200 years. And they're often focused on threats to economies which are largely dependent on imported raw materials. And perhaps the European economy is the best example of that. And the criticality concept was invented during the Cold War to help governments and industry understand and mitigate those threats to material supply security. We normally think about criticality in terms of a two-axis graph which looks at economic importance along one axis and risk to supply disruption along the other axis. And you can see there that cartoon just shows it very typically plots that way. If you look at what comes out of the European Union or what comes out of the UK or the US, it tends to be plotted on graphs that look something like that. with the most critical, the most important of these metals, they're usually metals, plotting in the top right-hand corner. This methodology can also take into account environmental and ethical issues, and it can be done on a range of bases, from a bloc like the EU to a country like the UK to a particular economic sector, say like renewable energy, or many companies do this themselves and look at their own raw material needs in this way. When we're talking about these metals required for the energy transition, we're often talking about, they're sometimes called critical, they're sometimes called technology metals. They're really, really important to the function of renewable energy technologies, zero emission transport technologies, and other industries. But many of them, as this diagram shows, are only used in relatively small amounts compared to industrial metals and ores and all metals and ores. So the biggest thing that we produce, the largest commodity we produce on the planet as a metal is iron and steel. And you can see from this diagram that industrial metals like copper and chrome and manganese are produced in much smaller quantities. And then if you go, you can go down an order of magnitude again to go to some of these metals that we're talking about for the energy transition, like lithium and cobalt and tungsten. And even with the big projections in demand for the increase in our use of renewable technology and zero emission transport technologies, the tonnage of these so-called technology or critical metals is relatively small, and much smaller than many of the other metals we use. So we have to get this problem in perspective as well, particularly when we're thinking about where these metals are coming from and how they're processed. And I'm a geologist, so I want to talk a little bit about scarcity and the concerns about scarcity. And again, these have been around for a long time. I'm old enough to remember the Limits for Growth report in the 1970s, and there have been articles since, including this one on the left here, which was an article published in the New Scientist magazine back in the 2010s. And there's a lot of concern, particularly amongst the media and amongst journalists, amongst politicians, around us physically running out of metal. And I can tell you now, as a geologist, although the Earth is a finite system, there's no prospect of physical exhaustion of these minerals and metals in the foreseeable future. So when we talk about the criticality of these things and about supply, what we're really talking about is concerns about disruption to supply, about securing access to critical raw materials, not running out of them. So just a few slides to finish on talking about what we need to think about, certainly in a policy context, around ensuring a secure and sustainable supply of critical raw materials, particularly to European economies. And that's really around diversity of supply. So we really need to think about this in three ways. Global primary sources, that's metals and minerals mined outside the UK and Europe, and I would include deep sea minerals in this category. Domestic primary sources, so those are metals and minerals mined in Europe. And secondary resources, again, the chair mentioned at this beginning, derived from the circular economy, derived from recycled material. And there are pros and cons to all these approaches. And the biggest pro of global primary resources is that we are a group of trading nations. We have a proven track record of supply from global primary sources for critical raw materials. We've been, in fact, trading in these critical raw materials, really for 2,000 years since the Bronze Age. So you could argue that we've done that successfully for a long time. Why do we need to be that concerned about it now? We should be concerned, but anyway. And we know that this is a proven route, and it's a reliable route that we have seen very little supply disruption, and we can buy these metals and minerals at competitive prices because they're produced where the lowest marginal cost of production. In terms of the cons, though, and again, I'd refer you back to that fact that although critical raw materials are very important, we still produce them and will need them in relatively small quantities compared to other metals. Therefore, production and refining tends to get concentrated in a few locations. They're vulnerable to, because of this small volume, they're vulnerable to price volatility, they're vulnerable to capture by competitors, and that might mean other companies, or it might mean state actors, as we've seen recently, geopolitics and other supply disruptions. They often have long and complex onward supply chains, which are vulnerable to the same thing, to that capture and to price volatility. And of course, in the context of this meeting today, what's really, really important is we are, in the case of deep sea minerals, literally offshoring our environmental obligations. So we're often enjoying the benefits of these materials without having to put up the environmental and ethical problems that go with their production. Domestic primary resources, there's a lot of interest in this in the UK at the moment. The big pros around supply security, we literally own the resource. We may or may not own the value chain, the supply chain. And we, of course, onshore our ethical and environmental impacts. But of course, in Europe, and particularly in the UK, we lack domestic capacity to supply. We don't always have the downstream processing and smelting. We don't have the skills often, we don't have the investment, and there can be very long lead times associated with getting these projects going. In the UK's sense, and I think in most of Western Europe certainly, we don't always have the geological understanding about where these resources are. There's issues around getting access, permitting issues. Local populations don't like these developments very much. It's hard to attract investment, and again, there can be long lead times. And because European resources are often relatively small, it's harder to achieve those economies of scale that you need to produce to compete, and they can be vulnerable to being closed down by competition from other places around the world. We mentioned the circular economy. This is very important, and again, in terms of the advantages, it gives us supply security, it gives us ownership of the value chain, it enables us to capture those environmental impacts, but as long as global consumption is increasing, then we will continue to need primary raw materials. We don't have very much data about what's available out there, of what's available in use stocks, in material that's being used at the moment. When will it come to the end of its life? We don't really understand the system very well. And there can be this lack of capacity to supply. We don't observe regulation, the right regulation, collection, processing, refining, infrastructure, long lead time. And again, achieving those economies of scale, getting the investment, and these materials are just as vulnerable to competition from cheaper products from elsewhere. In terms of that, why can't we just get all our supply from recycling? Well, as long as global consumption increases, we'll continue to need primary materials, mined materials. And that's because of this recycling gap. What's available for us to recycle now, in products that are coming to the end of their life, is not enough, given that demand is rising, and that will continue as long as demand continues to rise. So just to finish, what will give us that secure and sustainable supply to deliver net zero? Well, we need that access to a diverse range of critical raw materials from global sources, from including possibly deep sea minerals, from other places around the world, from our domestic resources, and from the circular economy. We also need to understand, because many of these metals, the problems of supply don't come from their availability in mines, they come from the vulnerabilities of the onward supply chains, and the fact that very often these supply chains are in the hands of a very, very small number of companies or states. And of course, finally, and probably most importantly in terms of this conference, security and sustainability requires understanding the environment, the environmental, social and geopolitical impacts of supply. So on that note, thank you very much, and I'm happy to answer some questions later. Thank you.
Thank you, Andrew, and thank you for setting the global stage. The next speaker is Pedro, who will give a brief talk about the regulatory framework in Norway at present.
Hello everyone. I'll just switch off my mic. Yeah, I think it's working. Is it working? Yeah. So do I just press? Yeah. So I was challenged to present status on deep seabed mining regulations in 5 minutes, which of course is not possible. So I will just do a very brief and very simplified overview of what are the current regulations in both areas beyond national jurisdiction and in the Norwegian case. So in the areas beyond national jurisdiction, is the International Seabed Authority that regulates not only seabed mining, but also the effective protection of the environment. So, kind of shall we say, it could be, on first sight, kind of a conflictual situation here. But the ISA is actually mandated by the United Nations Convention on the Law of the Sea that establishes that mineral resources that are harvested in international areas are common heritage of humankind and should not be allocated or monopoly of companies that exploit. And also, very important is that mineral activities have to be conducted without serious harm to the environment. Of course, serious harm is not an objective criteria, and it's actually something that is under debate to understand and to quantify what is serious harm to the environment. This is one of the big challenges that we have nowadays. Several exploration licenses have been awarded. This information is on the internet. It's published on several reports. I'm showing here only the CCZ exploration areas for polymetallic nodules, where you have all the different colors are different license areas that are usually allocated to a sponsor state who apply for these licenses. And these squares here that you see around the nodule exploration areas are areas of particular environmental interest. So it's interesting to see how they are, most of them are around these polymetallic nodule areas and not within. And we know from studies that there is a lot of heterogeneity in the seafloor, which means that some of these areas are not representative of the areas that will be eventually exploited. Currently, there are draft regulations being debated for the exploitation of seabed minerals, and also regional environmental management plans that are being developed. There are drafts that are being under discussion and developed. I'll just put 2 examples here, but there are more documents that also establish guidelines for how an environmental management and monitoring plan should be implemented, etc. So this is something that is pretty much under debate, and hopefully there will be a conclusion to the process in the next couple of years, maybe earlier. Don't know. So moving to the Norwegian case, of course, the base for the whole seabed mineral activity in Norwegian areas is the Subsea Minerals Act. This was published in July 2019. It regulates, or it will intend to regulate, mining exploitation in the Norwegian Continental Shelf, in deep sea areas of the, we should not call it Continental Shelf, because these are shallower areas, but in the deep sea areas of the Norwegian jurisdiction. It establishes principles for mineral exploitation in agreement with several goals, and most importantly, it stipulated an opening process that is currently underway. There's a bit of unfurlment in there, I'm sorry. an opening process that started soon after the enforcement of this Subsea Minerals Act. And the opening process is led by the Ministry of Petroleum and Energy, who have mandated NPD, the Norwegian Petroleum Directorate, to conduct the assessment study, to coordinate it, to ask relevant agencies to conduct these studies. And the NPD is also carrying out resource mapping in this area that you see here in brown. So it's a huge area, it's nearly 600,000 square kilometers. So I would say that it will take a while to be able to map this area in a satisfactory way. And when we say mapping, it's looking for mineral resources, whereas other research institutions, including UIB, are looking into the environmental characterization of the area. So this assessment study started with the publication of a program, and the program was under public consultation. There were numerous agencies in Norway providing feedback to this program and trying to improve it or trying to highlight possible shortcomings. And these comments will be incorporated in the final report, the final impact assessment that is now underway. There are background reports. The University of Bergen was responsible for the seafloor environment, for the geological and biological aspects. So what we know about this environment, so it's current knowledge, and it's not considering studies that are underway, and that will take still some time to be concluded, and a time that is beyond the timeline for this opening process. This is my final slide. We are more or less here in this stage, investigating. There was a tender for environmental impact assessment study that is based, again, on current knowledge. There is no time until 2023 to produce the significant knowledge, the significant information that is required for environmental management of this deep sea mining. So when this environmental impact assessment report comes out, and it will be again under public consultation, it will be very interesting to see the conclusions. And I would say that one of the conclusions is that we need more research that has to go beyond June 2023. I will talk a little bit more about this in my second presentation. I think this is my last slide for now. Yeah, so this is the next one. Thank you very much.
Thank you, Pedro, for setting the local regulatory stage. Then we will move on to the next speaker, who is Walter Somnes, who will speak on the economic industrial potential of deep sea mining. So Walter, nice to have you with us. And we see you clearly. Can we hear you also?
Yes, I hope you can hear me.
We can hear you. So just go ahead with your presentation.
Thank you, then I will start sharing my presentation here. Let's see.
Yep.
Yeah. Is that okay?
We can't see it in screen mode, but we see your cursor has moved. Try to. So we only see it. We don't see it in presentation mode.
Okay. Let me. I don't know. Let me see. Let me see. So. Do you see it now?
Yeah.
Okay.
It's fine.
Yeah. I'm sorry. I'm more used to Teams than Zoom, but okay. So I'm a geophysicist by background, and I'm gonna talk about the industrial view from the side. We usually also talk all about we just covered by Andrew earlier about the potential need or the market for deep sea minerals, but I will try and concentrate on the industrial side. Luke, we were established a few years ago, and we come from the oil and gas industry. And I think, and I'm convinced that the oil and gas industry holds the key to unlock the resources in the deep oceans in a sustainable way. I will come back a little bit to that. The picture you see here, the front page, is our concept of reducing manganese crust, where we use ROV technology, a very familiar technology from the oil and gas industry. And we think this is a way to do it with a minimum environmental impact. So, see, yeah. Andrew then was touching, going through this about do we need what this the green transition really is, and I'm here referring to the two reports that the International Energy Agency gave out last year. The one to the right, net zero by 2050, is very well known and referred to by many. But just before, a few weeks before that report, the same agency gave out a flagship report of the role of critical minerals and in a clean energy transition. And basically, what I'm stating here, you cannot have the one without the other. You cannot go away from hydrocarbons without saying you need more minerals. And you kind of going into a metal mineral energy market. And I'm not going to dwell more on that, just a statement that I think is important to have. Then, so I think, then I'm going into more the industrial part. The green energy transition really starts with mineral exploration. I think quite a lot of stakeholders, they start at the end here with the batteries or the storage and energy infrastructure. But to come to that way, you have to start with the exploration and mining. As was stated by Andrew, recycling cannot solve that problem today. Maybe in 50 or 60 or 100 years, recycling will be a more important role. But before that, you will start with the exploration and production. And that's where Luke is important. It's in the exploration and production of minerals. And then you have the whole value chain, shipping, onshore, logistic and processing. And I think here you can see that Norway could play a very important role independently on not only about the resources we potentially have in our own exclusive economic zone, but also for Europe and the Western world, we could be the supply of critical minerals. And that's kind of the, if I could say, the dream we have, that we could start this transition going away from the oil and gas industry and moving into this industry where we can build on the technology and expertise we have developed in the oil and gas industry. Below here is just some of the partners that we have. We have, especially I would like to take on the Technique FMC and Wilhelmsen Group, which is also our cornerstone investor, but also the Kongsberg Group, which we have good technology, very strong technology development with. We are basing our technology on the oil and gas industry. Coming back to what we saw when we started this process with the establishing, we saw that the technology development was very needed. And again, the key to this technology we could take from the oil and gas industry. We think it's very important that we can build on the Norwegian offshore and subsea technology, and we can see that this is the way we could both explore and produce the marine deep sea minerals in a sustainable way. It's also important, if you look at the exploration side, for instance, that exploration, mapping of the resources and environmental mapping can be done hand in hand. We are today working together with Kongsberg Maritime on using their Hugin, their AOV platform, to both do resource mapping but also environmental mapping. So during the period when we do explore, we will also know much more about the environmental mapping of the areas. Similar is also with the nodule. I must also say that we are only looking for currently at manganese crust and manganese nodules. That is our two main deposits: manganese crust in Norway and Norwegian waters, and manganese nodules in international waters. And the pictures here are showing the different production system to the right and the exploration technology to the left. So here I'm just going to go over a description on the manganese nodule production system we are developing. Again, it's based on oil and gas, subsea oil and gas technology, and what we see is there are actually very few technology gaps. That is maybe in contradiction to a lot of reports, but it's very similar to how we produce oil and gas from deep waters. And remember, the only industry that has operated on very deep water is actually the oil and gas industry. And what we are looking at here is when we started, we looked at we needed to do this in the best possible environmental way. And of course, one of the big issues with nodule production is the plume horizontal, where you harvest all the nodules up from the seabed and all the sediments that you take with you. What we are looking at here is we're going to look, instead of taking all the sand with us, we're only picking up the nodules. So we have no sediment returning. So the few percentage of sediment that comes with the nodules are being part of the bulk transport to the processing. In addition, we are planning to have a closed loop with the water, so the return water will be closed inside the riser system. So the whole plume discussion from the return water can be kind of neglected. It's only the impact you do on the seabed, and here we are doing very light machines. The machine you see here will only be 5 meters in width, and all the heavy equipment will be at the pump station further on there. So these are very light and with minimum impact on the seabed. So this is the way where we think the oil and gas industry and Norwegian industry can play a major role in getting access to these minerals in the most possible sustainable way. And now I'm just going to briefly talk a little bit also about the impact of that. Here I'm talking about we are going away on taking away the plume discussion, but also if you look at the footprint, here is the footprint, and this is the familiar map as you saw. This is from the Clipperton soil. And as Pedro said, that yes, there are restricted areas around, but what you must remember here is the size. This is the area here is 4.5 million square meters. The first white one there is 20 square kilometers. That is 100 years of production from one vessel. The other one there is 80,000. That is 20 years production for 20 vessels. That represents approximately 2% of this area. So what we need to understand here, when we see this, it's only a fraction of this area that actually will be developed for mining. It's only a small fraction which can cover substantial, a large portion of the mineral or critical mineral market that we're going to see developing in the future. So that was all I have to say today. Thank you.
Thank you, Walter, and I hope you will be with us for the panel discussion afterwards.
Yes.
And then we will switch to Pedro's second intervention here.
It's me again. Thank you. It's a bit. Is it possible to zoom in out? Let's see how much it's got. No? Okay. Right, so now we'll talk about a little bit more about what I do and my research team at the University of Bergen. I'm of course a deep sea ecologist, and I'm happy to show a lot of animals, but also discuss what are the relevant environmental scientific gaps that prevent environmental management of deep sea mining. So this animal that you see here, I will not explain all of them, but this is actually a glass sponge. It's made of glass fibers. It's a pumping organism. It filters the seawater, and it can create very extensive grounds that are vulnerable ecosystems, and they are supporting other life on the seabed. And this picture is, this sponge is attached to an extinct chimney at 3,000 meters depth in the Norwegian deep sea. So what knowledge do we need? Of course, we need a comprehensive understanding of the natural environment. This is what we call the baseline. But however, we also need to understand the potential impacts of deep seabed mining. To the best of our knowledge, it will be a very complex operation that will involve equipment, machinery on the seafloor. It will involve a system that can provide power and that can pump the mine material up to surface vessels, and then eventually release the dewatered material back into the water column. So this is a very complex system. We need to understand more of how the mining operations will take place. And this is something that so far has been either not developed or under confidentiality from companies that wish to develop such technology. And of course, we need to understand and to develop effective monitoring and mitigation strategies for deep sea mining. And I would say this is in its infancy. This is part of the European Union's strategy for priority research in the next few years. I will not go through this in much detail, just to say that with regards to environmental baselines, of course, we need to understand the environment, the abiotic environment. We need to understand the oceanographic conditions, turbidity, oxygen, ocean currents, all the properties of, and also the seabed properties in the areas that are associated with marine minerals. On the side of the biotic factors, on the side of the biology, of course, we need to know what lives there, how the species are associated with each other, what is their ecology, so how does the community work, how the species interact. We need to understand connectivity, so how populations of organisms in different areas exchange individuals, and they can supply new individuals to areas that are eventually going to be disturbed. But above all, this is the take-home message. We need to understand pattern and processes in the deep sea. And this is something that we don't understand. That we have very, very important gaps regarding pattern and processes. So what occurs where, and which factors, parameters are responsible for maintaining these communities as they are, and I mean in the natural condition. And very important, we need to understand variability. And to understand variability, we need time. We need to conduct the same kind of measurements and surveys repeatedly, preferably autonomously, so continuous recording of data, so that we understand natural variability to be able to detect what is not natural variability. So to be able to detect what could be caused by disturbance from mining or from any other activity. When it comes to environmental impacts, of course, we need to understand potential impacts. And when we talk about seabed mining, we mean the removal of habitat where the minerals occur, the generation of sediment plumes that can have cause physical disturbance just by the fact that they can cover the organisms, but also toxic effects, because we can release metals that will be dissolved in the water column and they can be toxic to the organisms. Noise, light, so any kind of disturbance caused by the machinery. You have to remember these deep sea habitats, they are not used to unnatural noise, and they are not used to light. So this would be a huge source of disturbance. And most importantly, cumulative impacts. It can be argued that one mining operation can have a very restricted influence. However, it is not realistic to consider that there will be only one mining operation, one mining license. So it is important to understand what several mining operations at the same time, what kind of buildup of impact this can have in the wider region. So cumulative impacts, of course, very important. We need to understand how the ecosystem, how the organism, the communities can resist the disturbance, but also how they can recover, if they can ever recover, because some of these mineral resources are not renewable in our time scale. We are talking about millions of years for a polymetallic nodule to form, or a manganese crust on a seamount. So these are timescales that escape our understanding. We need also to investigate restoration approaches. So in the event that we can do something to recover those environments, what are the strategies? How much will it cost? Who will cover these costs? And we need to try them out before this can be adopted. And of course, for management and monitoring, we need to know which goals we want to achieve, what are the parameters we want to measure, and what are the bounds, the values that we consider acceptable for these parameters to stay within an acceptable level of impact. When we talk about the Norwegian area, we consider two mineral resources. Polymetallic sulfides, they are formed at black smoker hydrothermal vents. They release this black fluid that is full of metals, and then the metals will deposit around these hydrothermal vents. Eventually the vent will go extinct or inactive, and the kind of community that you see changes. So it will no longer be the ecosystem, or let's say the biological community will change when the activity ceases, and we are left with the remnants of the chimneys or the collapsed chimneys that will form mounds. And the other mineral resources are manganese crust. These are formed on seamounts through very, very slow precipitation of minerals on the flank or the top of the seamount. Again, they can have several centimeters in thickness, and below you have the basalt. And again, this can take millions of years to form, which means that if they are removed, we cannot consider recovery in our understandable time scale. A brief overview of the ecosystems associated with Arctic deep sea ecosystems. So of course, as I mentioned, we have hydrothermal vents. These are very rare and isolated. Some of these vent fields are smaller than this room, and they are scattered many miles apart along the ridge, along the Arctic mid-ocean ridge, and along the ridges throughout the world. They host specific fauna that only lives in active vents. They have particular association with microbes that grow on these vents. So if the vent goes extinct, the faunal community will change. And many of the species that we see here in the Nordic seas and in the Arctic are endemic to this region, which means that if they go locally extinct, this will be global extinction. And of course, there's a lot of research being done, part of it at the University of Bergen, investigating the biotechnological potential of these microbes, but also of the other organisms. What we know about active vents, they are actually very charismatic, so I would say this is the habitat for which we know relatively more. But I would say that the smaller fauna is not very well understood. We don't know connectivity patterns, and even the ecology, which requires long studies and experiments and observations, is also poorly investigated. When the vents go extinct, then we have inactive or extinct hydrothermal vents, and then they have a completely different community. These are carnivorous sponges. This is a cousin of the first sponge I showed you, but this one is carnivorous. They don't filter the water, they capture animals. So it's a pretty cool animal. And because they are less charismatic, there has been virtually no research on this kind of community. And these are the ones that are associated with potential deposits that can be mined. So most of the old deposits will be buried under sediment. But there are also deposits, more recent deposits, that are not buried under sediment, and they can host this kind of community. Of course, seamounts. They are isolated features on the seafloor. They are hotspots of biodiversity, hotspots of biomass. They influence not just the benthic community, but also fish communities that aggregate around these seamounts, which means that if there is a disturbance caused by exploitation of manganese crust on the seamount, even if it's localized on the seamount, it can have widespread effects, because for one very special reason, is because we only have, and I mean in the Norwegian area, we only have research, exhaustive research or comprehensive research for one seamount, and that's the Schultzbank, which means that we don't know, we cannot extrapolate what kind of impacts a large-scale mining operation can have in the region. And we don't know, of course, how connectivity works, so how the different seamounts are connected through the migration of larvae, the dispersal of larvae between seamounts, and even of animals between seamounts. So a big priority would be to replicate the kind of studies that have been done on the Schultz to other seamounts. Soft sediment, this is the, let's say, the poor cousin of deep sea benthic ecosystems, because apparently nothing lives there. This is actually a good picture. It shows a shrimp and a fish. And from visual surveys, you don't see what lives there, but I can assure you that many of these dots are actually small animals. And it's not only that. Within the sediment, that's where the real biodiversity exists, and that's where the real biogeochemical cycling occurs. It's bioorganisms that we don't even see, that we cannot even see. And why is it important to survey these areas that are the most abundant habitat in the deep sea? Well, it is important because we do not understand the biogeography of these organisms. Again, we do not understand what cumulative impacts of exploring several extinct deposits that are buried under the sediment can have in the wider ecosystem. And for this specific kind of study, we are starting to use eDNA, so molecular methods, DNA methods that can screen samples of sediment and from where we can have a species case. And this is a rapid assessment of biodiversity. Of course, it's a huge area because it's the most widespread habitat in the sea. So to sum it up, and this is the outcome of one of the reports that we produced, that UIB produced in this opening process. As you can see, our level of understanding of the habitat is still very basic, meaning that it's satisfactory in terms of, and for certain cases, in terms of sampling. However, when we go for the higher levels of research or knowledge, to understand the processes, understand connectivity, ecology, ecosystem functions, we are in the red, which means that for environmental management, this is really a no-no, which means that we scientists cannot provide a validated, qualified, science-based recommendation for environmental management of deep sea mining in Norway. So in conclusion, what I would like to say above all is that seabed minerals, they coexist with fragile and rare ecosystems about which we know insufficiently. We don't know enough about these habitats. So the science gaps cannot allow us to recommend policymakers, to provide the recommendations to policymakers. And closing those gaps will take time, and it will take considerable research effort. Deep sea research takes a lot of resources, a lot of time, logistics, also a lot of technology, and sometimes it breaks down. And it's much simpler than mining machinery, but still, in a way, but still visiting and researching at these depths is still quite an endeavor. So we need time for that. We need time to collect the necessary data. And of course, collaboration among all stakeholders is essential, because we can provide, as a biologist, we can provide information on the environment, but we do not know how the mining operations will take place. And this is something that has to come together so that we can produce relevant information in the context of deep sea mining. And again, this is on sulfides. It's one of the target areas for mining. You can see all these small animals. These are 2 millimeters. These little snails are 2 millimeters long. So, there is life there, abundant life, and size doesn't always matter. That's what I would like to say. Thank you very much.
And can you just give her a microphone? So then it's a pleasure to get an NGO perspective on this from Kaja Fjatoft.
Thank you. Let's see if I can get this all to work. Yeah, perfect. And there we go. All right. So hello, everyone. And thank you so much for the University of Bergen and Academia Europa for inviting us to give a... So my name is Kaja Fjatoft. I'm a marine biology / marine tech person. I come from a background from the Norwegian Environment Agency, where I worked with petroleum, but also deep seabed mining. And now I work at Worldwide Fund for Nature, and I work with deep seabed mining as one of my main tasks. So I wanted to give you just a couple of points of background of who we are as an NGO and maybe why you should listen to us. So we're actually the world's largest independent conservation organization. We have over 100 different offices spread around the world and over 6,000 employees. And one of the reasons that I want to bring this up is because when we talk about issues, for instance, like deep seabed mining, we are not talking just about Norway. We try to look at all of the work we do also in a global perspective. And we are able to do that also because we can discuss with colleagues that sit all around the globe, for instance, in the Pacific, which Walter was talking about, or in areas around other exploitation activities, and actually have a dialogue across different stakeholder groups and different communities. We also fund work through the NORAD program in about 20 different countries from the office here in Norway. So we also do quite a lot of capacity building work. We understand that, reversing the decline of nature, which is kind of the one task that we want to work towards, we cannot do it alone. We actually need to collaborate. So we try to work across what we call 3 different levers. We talk, of course, to policymakers, we talk to governments, we talk to them about what policies can be effective, what do we actually need to do. We also talk to businesses, and we try to collaborate with businesses to kind of create lasting systemic change together. So, we're not looking at businesses just as donors or kind of across the room. We try to engage with businesses and also understand different perspectives. And then, of course, we talk to the people, and we try to provide the people with the knowledge that they need to actually demand the change that we want. So we try to create systemic change by working kind of across all of the different areas here. Deep seabed mining is kind of a relatively new area for Worldwide Fund. We started working on it maybe 4 or 5 years ago. We work in it together with the International Seabed Authority and as an observer in there. And we also work quite a lot with it in Norway. And instead of giving you now a really long PowerPoint presentation, I actually thought I would show you this video from Seas at Risk, developed in 2017, that I think summarizes the issue quite well in also quite a fun way. So let's see if we can check it out now.
Mr. Smash It.
In pyjamas. Every night before I hit the sheets, I check under my bed to see if any monster's there. I want them to be fed. And there are loads, and that's because of whether I choose to snore. The seafloor of my bed, that's what I said. The seabed is my dance floor. Creatures ugly, strange and weird, they love it on my bed. The pressure's high, the heat is low. It's crazy, like I said. Oh yeah, it's dark as night with fancy lights and frankly strange good know. Coral plumes, hydrothermal fluid, low dance far out for sure. Feeling lucky.
My tipsy disco, take it deep down there. I said, come on, take my tipsy disco. Just push me down there.
Metals are required for high-tech merchandise. So I'll grant plans to meet demand for that sexy new device. What we're going to do this taste for all else people and supplies. We don't like a roll, big deep holes. What do you advise? Is this good there?
If we change the price for weight, the whole economy's fine. Don't make this throw away.
What? Let's give you a fire. I got an idea, but there's a risk. We'd have to plow up the ocean's discount. Man's gotta go where man's gotta go. Let's take the plunge. You probably say so. All agrees that a massive dig hole. Dig it deep down there. I said, come on, we plan to dig so. Let's dig it deep down there. Disco hit in 7-0, and I'll bet you know since then. Half all life in the sea has gone.
That's right, it's new to men. We know more about the planet Mars than Mama Nature's disco show. Imagine if we found any alive and then used without help.
Meet glowing blob, an anglerfish, and a luminescent squid.
I'm glad we met, but there's a threat.
From ore extraction kit. Take it out now. Lay down drills and snuff down, boys. Let's suck up the ocean floor. Dredge up the nodules, shred up the vents, then booty here galore.
Come on, dig that deep sea disco. We'll dig it deep down here. I said, come on, dig that deep sea disco. Dig deep things in here.
Dig, 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 it's rather loud. The well's no longer here. The toxic sludge has made a cloud that's killed the atmosphere.
The one thing we all know for sure is the seabed groove is slow. Every piece we've taken out has still yet to regrow.
If you dig and chuck to make a buck, you rip a scratch across the sea. But make stuff to reutilize and run its history.
In the loop now, repair, recycle. Repair, recycle. Repair, recycle.
Lift the needle up. Lift the needle up.
Don't you dig my deep sea disco? Won't you dig down there? Please don't dig my deep sea disco. Disco's deep down there.
What is this? There's just no need to kill our disco dead. Your greed for all is such a bore. Just leave it in our bed.
Shake it up, the status quo. But don't you right down below.
Shake it up, the status quo, but don't you up or down below. Shake it up, the status quo, but don't you up or down below. Shake it up, the status quo, but don't you up or down below. Leave my down below alone.
So I hope that was kind of a nice way to introduce the topic from an NGO perspective without showing you a lot of different slides. So I just wanted to bring up this first slide to kind of just put the bigger perspective of what we're actually talking about when we're talking about deep seabed mining. And you've heard Pedro, you've heard Valta mention nodules, crusts, and I'm not sure if you're all kind of down with the lingo as we that work with it every day. But we're basically talking about 3 types of metal deposits. You have here the sulfides or hydrothermal vent systems or black smokers. It has a lot of different names. But these are what Pedro was showing us so nicely. These areas with this hot water that's coming from below the Earth's crust, penetrating through the crust, that dissolves a lot of things in the Earth's crust, including metals and minerals. When it comes then out to the cold deep sea water, it then kind of stiffens and then it makes these big structures on the seabed. And you have 3 categories, and you can think of them kind of like a volcano. You have the active ones, they're still spewing out the water. You have the inactive ones, the sleeping ones, like a sleeping volcano. They're not doing it right now, but they can reactivate. And then you have the extinct ones, and they have been moved through the spreading of the continental plates so far away from actually that hot water deposit that they are no longer able to reactivate. So those are the 3 types of hydrothermal vent systems. Then we have manganese nodules, or these kind of potato-like looking things. They're actually the size of a potato, so it's quite a nice way to look at it. And they are more found in the abyssal plains or areas like the Pacific. And we don't expect to have them here in Norwegian waters because we have such high sedimentation rates. And then the last ones are the manganese crusts. These are kind of on seamounts or bare bedrock. And if you have ever had a shower or been in a bathtub where there's a lot of calcium in the water, you get like the calcium buildup in your shower. It's the same thing, basically. It's just sticking onto a seamount. And then you get, over millions of years, these layers of metals. And the reason I'm trying to show this is also to show the complexity, because all of these have different types of tech that you would need to develop to possibility, like exploit them, but also very different types of ecosystems that are associated with them. And we have a very different level of knowledge when it comes to that. I'm not going to go through the impacts in great detail because Pedro did such an amazing job of already doing that. But I want to say that there are some irreversible impacts that we know will be associated with mining in the deep sea. But the really big point here is we do not know enough about the ecosystem to actually predict what the impact will be. So when you hear people say, oh, we're going to make a really low impact tech, they don't know. They cannot say that because they actually don't know the ecosystem and they don't know what they're vulnerable to. So you need to understand the ecosystem first, then you can start developing also in the association the technology. That's really important. And then the second point I want to make is it's not just about talking about the direct impacts of mining now, it's also about talking about the loss of future opportunities. For instance, from fisheries, if we impact our fisheries and our food systems and our ecosystems, so that we deplete our fish stock because you get toxic metals in the water, you get a lot of sound or noise pollution. That's really important to remember, especially here in Norway, really rely on fisheries. We need to make sure that we're understanding the impact on the fishery stocks. The second point is something called bioprospecting, which is kind of a bit sci-fi, but about 70% of the medicines we use here on our planet now actually come from the rainforest. And the deep sea has thought about kind of the new frontier for all of these scientific discoveries, because there's a lot of really cool deep sea life that lives there and it defends itself against a lot of different things than we do here up. So for instance, deep sea sponges, we found new types of antibiotics, and we've also found parts of the COVID vaccine in one of the sponges here in the deep sea. So that's really important to remember. The opening process in Norway was also covered briefly, but I also just wanted to put this a bit in perspective. The area we're talking about may be opening. It's not decided yet. It will be decided next year. It's about 600 square thousand kilometers, or approximately 1.5 times the land area of the entirety of Norway. It is absolutely massive. It's bigger than all the areas we've ever opened for petroleum activity. And we are here. So most of this area is in the Arctic, which is why I think it's so great that we're actually discussing this at Arctic Frontiers. This is all the way going all the way up to Svalbard and Spitsbergen. These are really vulnerable ecosystems that's already facing a lot of impact from climate change, biodiversity loss, and this will be an added pressure onto an other stressed Arctic environment. The second point I wanted to show you is this bathymetry map. We're actually showing what the seabed looks like here. So when we talked about Norway as a petroleum nation, we actually conduct petroleum activity here on what is actually the continental shelf. And then we have the extended areas, the extended continental shelf ocean areas, and deep seabed mining is happening over here. It's about 3,000 or 4,000 meters depth. When we're talking about petroleum activity in Norway, we're talking a couple of 100 meters. So yes, of course, there's some things from the tech world there that you could develop, but it's a completely different world when we're talking about pressure and also transporting things up to the surface. I wanted to bring up also two reports that I think is highly relevant in this discussion. The first report is the expert report from the high-level panel for a sustainable ocean economy that Norway took the initiative of creating, or the Ocean Panel for short. This report came out from their expert panel, and it discussed deep seabed mining briefly, but basically saying, at the knowledge level we have now, this could be in conflict with the Sustainable Development Goals. And I think Valto put it nicely with this, you have to solve both. That also applies to the climate and the nature crisis. We have an ongoing climate crisis, we all acknowledge that. We also have a massive ongoing biodiversity crisis. We've lost almost 70% of life in different populations with things with spines since 1970. That is crazy, and we need to also reverse that. You cannot solve the climate and nature crisis without solving them both together. So that's really, really important. And I think when the Ocean Panel's report came out, which is before Norway started the opening process, and it said so clearly, look, we need more knowledge of this area to actually say whether or not we should look into this. Norway still goes ahead with opening. I think that's not really showcasing the ocean leaders that we want to be. And then now in April, there was a white paper that came out from the World Economic Forum. They were super clear that their role is not to say yes or no to seabed mining, but they're looking at whether or not we have the decision that we need to actually make a knowledge-based decision. And they were really, really clear on the fact that we don't have enough knowledge, not just about biology, but also about minerals and which type of minerals do we need. Are there going to be different battery chemistries? What type of game-changing tech is happening? And we actually need to investigate further that aspect as well. And I also had a really nice quote which talked about, the age of metals, which Andrew so nicely told us about today. That in the age of metals, we really need to understand and learn from our past mistakes, and we need to develop the mineral industry in the future in balance with nature. Mining can never be sustainable. And you'll hear some of these deep sea kind of startups talking about sustainable mining. That doesn't exist. The mineral deposits take millions of years to develop, so within our kind of life, it will not be sustainable. But it can be responsible. And there's an initiative called the Initiative for Responsible Mining Assurance, which is a global initiative, and they classify kind of what's considered responsible mining and irresponsible. And they are also saying that deep seabed mining is not responsible today because we just don't have the knowledge. So we at Worldwide Fund for Nature are calling for a global moratorium together with a lot of different NGOs. And a moratorium is what we call a pause or a freeze until we have developed a set of criteria. We have a set of criteria that needs to be fulfilled. This includes knowledge about social environmental impacts, also economic impacts, but it also involves, for instance, transforming the International Seabed Authority so it's more transparent, involving indigenous peoples, local communities, also looking into the need for minerals and the circularity aspect, trying to look at those criteria and ensuring that we have the answers before we actually make a decision. And it's been signed, as you can see, by a lot of different companies around the globe, including big players and big automobile companies like BMW and Volvo and Google. And this is what we want our government to do and our world to do, is actually look at the common good for all humankind and stop, pause, think before we make a decision. Thank you.
So then I'll give the floor to Lisa Fowler. I see we are running a bit late. Our speakers have lots of things to convey to you. So hopefully we can go a bit over time for the panel afterwards. And I hope you will be still with us also after we close that.
I'll be quick, Dr. Jensen. This was a lot to absorb, and I'm certainly honored to have been invited, and I think my role as somebody who's been involved in sort of strategic thinking in a variety of issues in the Americas, Sub-Saharan Africa, and Central Asia, on relationships between communities, industry, oil, gas, mining in particular, governments, NGOs, and the environment itself. And so this one certainly strikes in the heart of all these dimensions. It's the front end, it's the cutting edge, if you use those terms, and as we're shifting from a green to a green economy. There is no question that this must be thought through and is being thought through in a manner that takes cognizance of all of its, or as many as possible of its dimensions. It was quite interesting to me to hear the corporate view, the NGO view, and certainly the science view. And science view saying, bringing up to a point of, okay, how do these ecosystems work? And what is the symphony that requires one upon the other that needs to be maintained? And what does occur to me is, given the fact that we've got basically a brand new industry that is emerging, it's the first time, pretty much the first time, I think, where the concepts, questions, discussions about the regulatory processes, if you will, or the implications of the scientific dimensions, there's an opportunity to get ahead of it. To get ahead of it before there's substantial mining both in domestic and international waters. And saying that in the context of, as there is increased interest internationally on protection for environment, so people are talking about, for example, the crime of ecocide, to put that within a framework of the international BICC, and or that nature has standing in and of itself. In U.S. courts and in Ecuadorian courts recently, there have been decisions made that the environment has standing and can bring an action on its own interests and own behalf. So things are shifting in that respect as well. And what it seems to me, if there's any nation, if I can say it this way without blushing or embarrassing anybody, if there's any nation that could take this on in an honest way, in a way, not perfect, but honest way, that brings together the science interests, the corporate interests, the environmental interests, the community interests, it would be Norway. When I was working in various locations, for example, in sub-Saharan Africa, I was in Namibia, and people were talking about the development of offshore mining, oil production, and what they said to me at the highest levels is that we want to do it the Norwegian way, and we're trying to bring in some folks from Norway to help us figure out what to do. And I bump into that all the time. I was on a Fulbright fellowship in Iceland, and that was when the Jan Mayen area, as we saw, was being considered for petroleum development with China's Seamount, which ultimately determined they're not going to move forward, which everyone breathed out. But I was in the National Energy Authority, Åkestofnen at the time, and there was a great discussion about the Norwegian model. So using the Norwegian model, whether you believe it's true or you don't believe it's true, that is the reputation. And so it seems to me that Norway has the opportunity to look at this in a really deep way, to sort of set the standard, if you will. My personal view is, and I could be wrong, is that the ISA, the UN's initiative, will take a very long time, and frankly, I trust Norway more. And international borders is obviously legally speaking a separate issue, but the dynamic will be the same whether it's on domestic waters or international waters in terms of any kind of a regulatory process or element. So what does that mean? Well, it would seem to me to start out with the idea of we're all in this together. And so whether it's the corporate folks, the World Wildlife Fund and NGO folks, or the science folks, to develop an approach or a process by which the conversations is sort of equal. Everybody's on the same level, having a conversation that's not an easy one, maybe, but puts the various interests on the table and discusses them quite thoroughly. I was actually part of a process like that at Harvard MIT on Arctic fisheries, actually, and it brought in people from all 8 Arctic nations. It brought in Greenpeace, ExxonMobil, Woods Hole, and people spoke in Chatham House Rules. This doesn't go out of the room, and it was very interesting to see the kinds of agreements, again, that wouldn't be made public, but were made in the room, agreements on process and dynamics. And it's a step. It seems to me that if I don't know, maybe it would be Bergen, University of Bergen, to host such, if I can say that without having asked, to host such a gathering and bringing in, as you have, the various players to have a discussion that starts from where we are we, and where do we want to go, and what's our next step, and to take it, and not to feel like there's a hurry for this, because there isn't, to the extent that perhaps there'll be a moratorium, and to think in terms of how do we want to move forward. And I would think that what comes from Norway would have an impact on other nations who are considering the same, including in the South Pacific, and then perhaps also the international, at the UN level. And so basically it's like, what do we want our future to look like, and how do we want to get there? And it seems that Norway and your processes are poised to help move in that direction, so thank you.
Thank you, Anita. And then can I have the on-site panel members up here on this side? And then let's see if we have our online.
Let's also you on the go. Or shall I just stay here? Or?
Oh, yes, that'd be good. So we can pass the microphone.
Okay.
And that's Andrew, and that's Walter. Okay, since we're running late, I'm just wanted just to pass the word around to see if what you think are the main issues that we have been raised here. Of course, there are very different perspectives. Maybe we should start with the issue of demand. Is it justified now to start this industry based on what we know of demand? Who would like to be the best?
Thank you. I think that's a really good perspective, and I think maybe the thing that hasn't been mentioned today that's important to also remember in terms of whether or not deep seabed mining should be a solution to demand is actually the fact that we are not ready, even if we open tomorrow, to mine the deep sea. This is not an industry that's ready for commercialization. We're still really at the test phase. And I went to a meeting with I'm not going to say who, the industry, and they said, anyone can make an animation, but you actually have to get the technology to work. So when we're talking about solutions to the mineral crisis and the green shift, we need minerals now. We need that to happen now. So we need to look at more circular solutions and responsible terrestrial practice if we're going to solve it for now.
Andrew.
Yeah, I think what I would say is that I agree with some of that. We do need more circular solutions, but the circular solutions are not going to deliver the issue now. They're not going to deliver the supply now. I think where I have problems with I have problems with deep sea mining for all sorts of reasons, but I think my main issue with it is that the Earth's crust is a big place and onshore, particularly for these metals that these are really, really important for the green shift. But in terms of the amounts we need, they're not relative to other things that we mine and relative to other commodities that we produce globally. The amounts required are relatively small, and as the World Economic Forum said, some of the demand scenarios for those are quite uncertain, depending on things like battery technologies, and which battery technologies the automotive industry, the global automotive industry chooses. So, I think in terms of, yes, we need these metals now, but actually largely they can, in fact, predominantly they're going to be supplied from both onshore conventional mining and increasingly from recycled sources. But as I say, recycled sources are going to take a long time to develop. I think, if you look at this issue globally, I think the main issue we have is not the commercial sector developing deep sea mining. I think it's state actors who are going to come in for other reasons to look at developing some of these deposits. Because some state actors have a big interest in this, and they have a big interest in capturing supply chains. So, to me, that's the bigger threat in the short term than perhaps large-scale commercial exploitation.
Walter, do you have a response to this?
Yeah, well, of course, have a lot of response, but I like to comment a little bit about when all the pictures we see about how the mining is done. It's a little bit frustration to see how they must understand the technology that we will have there, and they keep on showing these caterpillars machines and so on, and I think it's deliberate to show that it's going to be very harmful to do the mining, and that is what I'm trying to show, is that I agree there will be environmental impacts, but that will be the alternative. Is also, you have to remember, is terrestrial mining. There is an environmental impact. We think and we believe that the deep sea mining can be done in a in the very starting from scratch, we can apply very modern technology, and the monitoring and mapping is much easier to be done in the deep waters where we have autonomous vehicles, we have ROVs coming. It's very easy in a way to monitor quite a lot in the sea underwater than on land where you have groundwater pollutions and so on. So that, agreed, there are challenges, but the alternatives doesn't look that good either. And that is the issue. Terrestrial mining, if you look at the resources, there's almost not open any mine in the area except where China has control, if I'm going to take a little bit. So there is a solution, is that we can do this on the seabed with the highest, best technology and together with the environmental mapping and so on. So I think it's a little bit, the way you market that there is no technology today, absolutely. The oil and gas business has been in deep waters for tens of years, and we know how to do it. So the technology is actually there.
Okay, Pedro?
Thank you. A few comments, a couple of comments. First, I agree that the machinery that is being depicted more generally, that will be mining, is with caterpillars and contact with the seafloor. But we must remember that the only tests that have been done so far is with this kind of machinery. We don't have a proof of concept so far, or any tests, or nothing being that is, I don't doubt that is being developed, but the only tests that have been done so far are with bottom contact machinery. The second point I would like to highlight is that I don't know so much about demand. I'm not an expert. What I would say is that nowadays, I think that the supply chain of minerals has to be, societal acceptance is very important. And I wonder if companies nowadays, in their strategies, are able to cope with using minerals that don't have a source that ensures minimal environmental damage, like a certification. I am not sure that this would be even a good business model. And finally, just to say also for the Norwegian deep sea, I agree that we have automated methods for mapping. They are becoming more and more sophisticated. However, we must remember that the kind of seafloor that we are talking about is extremely, it's not flat, it's not like in the Pacific. And actually using AUVs, which is autonomous vehicles, to map the seafloor, at least in terms of the biology, I don't know so much about the geological resource, but at least in terms of biology, is a huge challenge. And it's not as straightforward as in flatter areas of the seabed.
Can I just point another question to you, and you may, which basically was touched upon by Walter. Everything we do when we extract resources have environmental impacts. So what's the difference between this and food production or other human activities that already has transformed our planet into the Anthropocene? So if you would like to comment on that as well. But who was the next?
Do you want to say that?
Just one quick thing.
Yeah.
Go for it. Thank you. I forgot who I think made a comment about that most of the forward movement is probably going to come from governments rather than corporate at this stage, which I would agree with that. And it seems like, for example, some of the island nations in the South Pacific, so small island nation with their internal jurisdictional waters, and then the international waters contiguous. So it's a prime areas, and I would think that probably is likely to unfold as well. And I guess I come back to Norway, which is to move forward in all of these, to bring all these various dimensions together, the science questions, the NGO questions, that don't go there questions, and we really need to do this as a next step in terms of green economy, that to put those questions like that are not being asked elsewhere. and not in the South Pacific, and partly because, and it's not just the South Pacific, other nations as well, who are looking at revenue generation, in a development world, in a development context frame of reference. So it's pretty serious and pretty significant, and I would think that forward movement from Norway as well would have some impact, or could, on the international processes as well. So.
Great. Do you want me to try to answer your question there?
Yeah, and then I'll invite a few questions from the audience before we run.
So I think, especially maybe talking about petroleum, which Walter has brought up a couple of times, and saying that we know how to do this in the deep sea, we definitely don't know. And this is the main issue with deep seabed mining. We don't know. We don't know what the impacts are going to be. We don't know how we're going to technically do it, and we don't understand our ecosystems. And when we're talking about the other pressures that are happening at our planet at the moment, with food production, also terrestrial mining, at least we know the consequence, so we kind of understand what our impacts are. And I think a really relevant comparison to terrestrial mining and whether or not we accept child labor and the environmental impacts of it is looking also to the clothing industry, which has had a huge problem with some of the same issues, with child labor, with a lot of environmental and chemical pollutants. And that's actually a human problem. We can decide as humanity what we accept. We can decide what products we want to buy, and initiatives like the Responsible Mining Insurance set those criteria and say, child labor, unacceptable. We're not going to have that. And then we need to have, I think, as Anita says, a dialogue across, and we need to actually come together as humanity and try to find solutions that are within planetary boundaries. Because the climate and nature crisis, we need to solve it together and not do massive natural damage to kind of save our climate. That will end up, I think, damaging us in the long term.
And then, if there are questions from the audience, I will walk around with the mic so that the online people here. Anybody, questions or comments?
Hi, I thought it was important for anybody who's late for something else, and this is my field of talk. My name is Catherine Donnelly, I'm the research coordinator at Transit here in Tromsø. And I would really like to thank the University of Bergen for this session, because I really enjoy that you presented science, politics, NGOs, and business in one. It's a really important dialogue. But I have to tell you that sitting here listening, I struggle incredibly with the, I'm an ecologist by background. And from everything I've heard, it seems to me that dialogue is important, and I'm struck by the input from the British Geological Survey that maybe it's not the obvious actors that we need to talk to. My question is to WWF. How do you think that your messaging and videos like that encourage actually reaching your aims in this department? Because it always seems to me that it's a bit jingoistic, and it takes tropes that we exist and places all actors into some kind of form. Do you really think that contributes to achieving your aim in this area or moratorium?
Okay, we need to run up here quite soon, so I'll give the word to all of you for a final remark.
Well, I guess I have to answer that question.
Yeah, so you can start, but this will be your final.
Okay, I think that that's a fair point. I will start by saying that, and it's actually, for me, it's also about, you go to conferences and there's a lot of heavy PowerPoint presentations. So it's trying to put it into, I think, seeing it from the back. I will say that we, as an organization, have met with Europaea, we met with Equinor, we met with all the big players. And I think dialogue is extremely important. I totally support that, and not kind of putting each other in categories. But I think it's also terrifying to see that in this opening process, you have the Norwegian Environment Agency, you have the Ministry of Climate and Energy, Environment, and they are coming out and saying, a year and a half ago, the process you've set up right now, for 2 years, it makes it impossible for us to make a knowledge-based decision. And then you still have actors pushing forward, and our government pushing forward. That means that the Norwegian model that Anita so nicely went through, it actually doesn't work. Because in our model, we need to make sure that the agencies we have in government are listened to and respected, and that we're taking care of, economy, yes, geological resources, yes, environment as well, and they need to be placed equally. So I think that is maybe the main message.
Okay.
Indeed, I would like to follow.
Anita,
Just 4 words to say thank you, beyond thank you, is that from the corporate point of view, how I view this is reputational advantage. To be a company that can be on the sort of leading edge of having the kind of mutuality of conversation to incorporate the various views and come up with a plan of moving forward. It may be a different corporate model, but in terms of reputational advantage and global appreciation, I think it's there without question. And in terms of science, industry, NGOs working together to grapple with a pretty difficult challenge for us as a global people and the planet itself, it's huge. So thank you.
Andrew.
Yeah, I agree about the corporate pressure in the West, or from consumer-facing industries like the car industry, like the consumer electronics industry, and that is having an impact on mining, full stop. But I would say, if you take the analogy with terrestrial mining and the impact that those sort of pressures have had, there are other factors at work here. And again, I come back to this thing about state actors, and that some state actors, some large state actors like China, do not see this problem in the same way we do. And I see that as a big challenge for the planet, really, is persuading people, the Chinese government, to see this problem in the same way that a lot of Western, us in the democratic West are seeing this problem. It's not the same, you know, mining, and not just mining, but the supply chain is not under the control of the West. So you have to see it that way, that if you want to change this, the big challenge is state actors, and particularly China.
Point well
we
taken.
have very little time,
I'll
so
just
you
do
need
one
to very
second.
brief.
Yeah, point well taken. And just to say that in my experiences in Southwest Africa, where there was China and the West located, each of the nations were attempting to balance China and in this instance the U.S. And I think that might be the case. And so it's not that China would just steamroll over, that there would be options, but your point well taken.
Walter, and then Perry, as the final word.
Let me first think, I strongly believe that deep sea mining is a better alternative than starting new mines in, say, in the Andes Mountains or in the rainforest. That is my belief, for many reasons, and I must question, and when you talk about you don't know, you don't think the technology is there, I think you must leave that to the technology people. We think the technology definitely is there, because it can be built on the technology we have worked for many years. And I think the geopolitical side is very important. China is totally dominating, and we can just look what is happening with Europe and gas supply now, and then you can just think 20 years ahead what's going to happen with mineral demand and the way the West and China are playing. So I think it's not a matter of whether you don't have terrestrial resources, it's a matter of who is controlling them and where you find them. And there I think the deep sea minerals are a good alternative. And remember, we have more minerals in the deep sea than we need to extract. We're just going to extract a small portion, and we will take out where it's easiest to take out with the most responsible way. Yeah.
Thank you, and the final short word.
Thank you. Well, we have seen here many different viewpoints, and that's the purpose of sessions like this. As a scientist, I want to say that we have two options. One of them is to take a leap of faith based on the fact that we need the metals and see what happens. Because there is not enough data to predict environmental impacts as we speak. So nothing replaces hard data, hard quantitative data to predict impacts and effects. And again, I am not authority, of course. The decision level is not at the scientists' level. However, the decision makers need to decide on what is an acceptable level of disturbance and an acceptable level of impact in these largely unknown ecosystems, or on the other hand, to allow for enough research to be conducted so that we can have an expert recommendation, which is what we are required to do.
Thank you, Pedro, and thank you to the panel for giving us a very broad and comprehensive overview of many of the issues involved here. Thanks to the audience for joining us. We got a challenge to the University of Bergen to continue this dialogue, and we will receive that challenge and see what we can do. So hopefully we'll see you again somewhere on this issue. Thank you.